Now, without any further delay, I would like to introduce today's presentation, 24 Hours of SQL Server 2008, Ensuring Business Continuity. It is my pleasure to present your first presenter, Bryan Van Axelson. Bryan, you have the floor.
Well, thank you very much, Phil, and welcome, everybody, as we continue on our journey of 24 hours of SQL Server 2008. As we get started today, we're going to take a look at business continuity and really focusing on availability of your database. So, you start to look at, do we have unplanned downtime of our systems? Obviously, that's going to have a negative effect on productivity and possibly profitability. We need to look at, what we can do to continue to protect our assets, but also look at, some design and architectural options that we have as we go to implement SQL Server and the database into our environment, and that's what we're going to kind of take a look at today. As we get started, I do like to point out, I did put it in the Q&A panel, my email address. But those of you that might be joining us on the recorded session, it's pretty straightforward. You'll see my name right there. So let me get my arrow here. There's my name, Bryan Von Axelson. So it's just brian.vonaxelson@microsoft.com. Again, brian.vonaxelson@microsoft.com. So here's kind of some of the bullet items. Let me go ahead and build our 3 bullet items that we're going to focus on today with today's webcast. As we take a look at SQL Server 2008, providing some different solutions to improve that availability concept. Now, the availability solutions are what I would consider, options that we have in terms of performance and variety, and we compete very well against any, competition of major database vendors, and I feel that, SQL with 2005 and now 2008 is leading the way in terms of manageability and value for your money. So as we look at this availability concept, we start to look at a couple of things. What happens if the server goes down? What if it has an actual physical hardware situation? Are we implementing clustering? Are we implementing database mirroring? Are we doing some type of peer-to-peer log transactional-based replication? Are we doing transactional log shipping? One of the other topics we're going to look at from availability perspective is, are users waiting? And that gets into what we consider optimistic and pessimistic locking. And by the sheer nature of a database software program, it typically is in a pessimistic state. And if you're not having any issues with locking, and this is, what I would consider an issue is you have people waiting for other users to finish making changes to the database or releasing the locks that they have as they're working within the database. A great tool to find out what's going on with your locks is one that we talked about early in the webcast series as we took a look at SQL Profiler. And during that webcast, I did mention how you can use the profiler to go out and see what's happening with the locks. But we're going to kind of do a demo today where I have an application and it's going to show you some of the things that we can do. And that's taking advantage of snapshot isolation. We're also going to take a look at database snapshots. So one of my pet peeves at Microsoft is we actually have 2 different technologies. We're going to talk about both of them today. One is database snapshots, and the other one is snapshot isolation. They both have the word snapshot in, but they are 2 distinctly different technologies, but they both do fall in the availability concept for SQL Server 2008. So here's some helpful experience. Those of us that have worked with SQL Server in the past, 2000, building on some of the things that we've had in 2005, and then also the concepts around clustering. But if you've been working with some of the competing database products, you'll be able to get some good information about how SQL implements the high availability option as we take a look at SQL Server 2008. So let's go ahead and get started. Basically broken down into 2 different areas, increasing availability and then decreasing downtime. And we're going to do a couple demos as we go throughout today. I expect to go close to an hour. We've been averaging anywhere from an hour to an hour and 15. I think we'll go, close to an hour. So we'll probably finish up. I'm in the Eastern time zone, so I have about 2:37. So I'm expecting to get wrapped up close to the 3:30, give you guys back a little bit of time because we are scheduled to go to 4. But I think we can get through the content today and get everything taken care of. So let's first talk about database mirroring. This is probably one of my favorite features, if not the #1 favorite features that was originally introduced in SQL Server 2005, has been changed and improved with SQL Server 2008, some nice improvements. So let's first talk about what the concept of database mirroring is, and then we'll kind of talk about some of the changes between 2005 and 2008. So here we're looking at, again, availability, so we're talking about system downtime. As we look at downtime, that can be caused by different issues: human error, natural disaster, hardware, software failure, application upgrade. So what can we do to have that always-on technology? Well, one of the first ones is database mirroring. And with the enhanced database mirroring, it eliminates the need to specify the failover partner, which enables existing applications to take advantage of mirroring, and that reduces the complexity of the database mirroring by enabling organizations to recover the principal after failover by temporarily disabling the mirror within the failover mechanism. So that's one of the changes for 2008, that you do not have to specify the failover partner. Another one of the changes focuses around the log compression routines that are used to transfer the information from one particular SQL server to the other SQL server. And I really liken this to the concept of hard disk mirroring. I think a lot of us have worked, with what I consider RAID 1, probably earlier in our careers. Hopefully we're not doing too many RAID 1 boxes now because the price of disk is so cheap. We're probably going RAID 5 or RAID 10. Definitely don't be doing RAID 1 and SQL instances. But as we look at, what is hard disk mirroring, it's basically a duplicate of the hard drive. And that's what database mirroring in SQL Server 2005 and 2008, respectively, it is a duplication of a particular instance of SQL Server. And that's what we're talking about. We're talking about having another instance of SQL Server. Now, in reality, you could put that other instance on the same physical box, but that's probably not going to do you much good when you lose the power supply. So, typically when we implement database mirroring, we're going to have a second box that we would have another instance of SQL Server installed on. Now, what's really nice about database mirroring as we compare it to clustering, you're going to see clustering in just a moment, is there are no hardware dependencies. You just need to have the server operating system installed. And it doesn't matter, if the boxes are from the same vendor. They're not sharing hard drives like you would see in a clustering scenario. And, they are two independent machines that are going to communicate over the network wire. And you can even do this on a WAN. So, another option that you can do this over a WAN wire to actually have the database mirroring. Basically what happens is you write information to what's considered the primary SQL database. It's going to send information to the other instance of SQL Server. Now you can just set this up in a couple different ways. You can set it up in synchronous and asynchronous manual failover mode. So both of those are failover. One is for performance, one is for protection of the data. So you think of asynchronous and synchronous communication. Asynchronous is we're going to write it to the primary, and then we're going to continue on. And then while we continue on, we're going to send the information out to the mirrored server. And with asynchronous, you do have a slight chance for data loss, but you're trading that off for better performance. Now, in synchronous database mirroring, you are going to have both machines complete the full write of the information before you continue on. Now, granted, folks, we're talking in milliseconds here. The only time you would see, what I consider a performance hit is if you do have a slow WAN link and you were to do this over a WAN wire. But, you're looking at, do I trade some performance or do I go for, making sure that I have my data? There's a third mode that you can run in as well, and this is automatic failover, and that's the one that I really like because that means no intervention from my part, and it automatically changes over. Now, this does require a third instance of SQL Server, and it's commonly referred to as what's called the witness instance. And with the witness instance, it is there to, as I've described it, I grew up in the 70s and 80s, and I loved the slush puppies, the Mr. Missies, the frozen Cokes, the ices. That's a drink that I used to have when I was a kid. And there was times when I would drink too much and I would get what's called brain freeze. Brain freeze actually made it into the Webster's Dictionary in 2005. But that's what the witness server is there to do. It's to eliminate brain freeze of the mirrored server. So let me explain how that happens. If the primary becomes disconnected for whatever reason, could be the network wire, could be the WAN link goes down, could be that the actual primary hardware box has suffered a casualty and it's gone down, for whatever reason, the mirror now sees it is disconnected from the primary. It asks the witness, and it asks this very simple question. It says, do you see the primary server? If the answer is yes, then the mirror just goes into an offline state and just kind of hangs out. Of course, you get some errors in the event log and things get triggered and that, but it's not going to do anything. However, if the witness comes back and says, no, I do not see the primary database server, then the mirrored instance now automatically promotes itself and takes over. And this is where that change for enhanced database mirroring in 2008 eliminates the need to specify that failover partner, so it's going to enable your existing application to take advantage of mirroring. What's the net of this? The net of this is if your primary server goes down, your application still runs, your users can still get to their information. We're talking about maintaining the availability. Now, as you go to, configure, the database mirroring, as you apply the changes, we're talking real time. So near real time would be the asynchronous. Real time is in synchronous. So again, you can specify that level of protection as well as the performance on your system. Now, with SQL Server 2008 Enterprise Edition, the mirroring protection is extended to pages of data. If a page is found to either be corrupt on the principal or mirror, the corresponding page is retrieved from its partner. So this is another major improvement with SQL Server 2008. So you can do mirroring with Standard Edition. You do need to have Standard or Enterprise. So let's talk a little bit about licensing, just because I think it's always great when I can talk about how Microsoft got it right, and this is one that we got it right. You're not charged for your other instance of database mirroring. So when you buy Standard or Enterprise, you have the rights to set up an instance on another box to be your mirrored server. So there is no extra charge for the database mirroring. If you want to do that high availability, as I mentioned, it does require a third instance of SQL Server. And what I recommend is you just use SQL Express. So you just download SQL Express, probably put it on a workstation, very light workload, not much going to be, traffic-wise on the witness. So again, you buy Standard Enterprise, you have the availability of implementing database mirroring. So let's talk about another availability. And this one's been around for a while. We've had log shipping for several versions of SQL Server. But the idea here is a backup is taken of the master server and then it's restored on one or more secondary servers. Log shipping applies, periodic log backups to the secondary servers. Although database mirroring can have only one mirrored server, log shipping can have many secondary servers. So here we have the ability to send it to multiple servers. Again, log shipping is also implemented sometimes over the WAN. Log shipping occurs on a schedule. Therefore, there will be a time delay between the data changing on the master and those changes transferring to the secondary server. But we can, hook this up so that we can have a minimal data loss. Now, there's another one that kind of falls in line. I didn't have a slide for it, but I kind of want to mention it. It was introduced with SQL Server 2005, and that is peer-to-peer replication. Now, that is transactional based, so it's kind of a little bit different than log shipping because, again, log shipping is on a scheduled basis. Peer-to-peer transactional replication happens on a transactional basis, so a little bit different than log shipping, but both of them similar in concept. So there we can see the schedule, and we're sending the information out. Now, the secondary server can act as a read-only reporting server, which is going to help reduce the workload of the primary server, but reports cannot be run while log backups are being applied. So we do have the ability to tap in and use them for read-only reporting server to help with the workload. As we compare that to database mirroring, you're not going to be able to do anything on the mirrored server. So it's just a mirrored server. Again, one of the new changes is the ability to restore the pages if there was an issue, but you're not going to be able to go and run reports against that mirrored server. Now, as we look at a scenario of a recruitment company, log shipping could be applied with a delay between the log backups and the restore on a standby server. That's going to allow the user error to be reversed if there's a failure on that primary server because the logs could be applied right away, and that's going to help reduce data loss. So next, let's take a look at failover clustering. And as we look at this one, we're looking at, again, a multiple server known as nodes. And here's one of the distinguishers between database mirroring and clustering. They do share a disk array in clustering. So again, the difference is, and you have to have clustering hardware, which typically you have to have certified clustering hardware. You need to have clustering operating system. You do have, a couple of what I consider added expenses, but also they do share a disk array. Now, if one node fails, its services can be started on another node in the cluster. So this solution is going to, again, help prevent any data loss. It's also going to provide that automatic client redirection. And, although, the failover from primary to secondary is not as fast as database mirroring, it is a, good solution, and again, we're talking, in the second. So, as we look at database mirroring, we're talking basically less than a minute, typically around what I would consider 10-second time frame on some of the things that I've been doing with database mirroring. With clustering, could be a minute. Could be a minute to get the services spun up. But again, both of them solutions. I kind of look at clustering as building upon the concept of database mirroring because you're scaling it out to multiple nodes, multiple servers. Now with Windows Server 2008, it's going to extend the clustering abilities of our previous versions of Windows, both by reducing the hardware and infrastructure requirements by supporting 16, it's set with 16 nodes in a cluster. Additionally, clustering is enhanced by removing the requirement that all nodes reside on the same subnet and by supporting or dependencies. For example, by ensuring that the network name resource is available if either of the two IP addresses resources is available. So some of that virtual networking. Overall, clustering is easier to set up as we look at moving to Server 2008 when we compare it to Server 2003. We also have a new cluster validation tool. So in Server 2008, we have the introduction of the cluster validation tool. That's going to make it easier to ensure that we have the adequate hardware resources for a clustered solution. So as we look at taking advantage of the cluster enhancements in Server 2008 with SQL Server 2008, we're going to be able to have that high availability solution for an entire SQL Server instance. And then also SQL Server does improve on the clustering abilities compared to some of the previous versions by removing the requirement to have one drive letter for each SQL Server instance, and therefore limiting the number of instances on a clustered solution. Now, as we look at doing this geographically dispersed failover clustering provides server-level redundancy on a certified Microsoft geographical dispersed cluster service configuration with one or more storage arrays at each site. If the site, the server node, or the disks fail, the complete redundancy of the system and disks allow the failover cluster to handle the different activities on another site. So that configuration removes the potential of a shared disk array failing and then preventing a standard cluster configuration from working. So here is the peer-to-peer replication. Again, changes are allowed on any database, can be applied to other nodes in the replication topology. As we look at close to real time, again, this is transactional based, as I mentioned, when comparing it to the log shipping a little bit earlier. One thing you need to be aware of is applications need to be designed to handle conflict resolution and to connect to another node if the topology, if the principal server is unavailable. So here you do need to build it into your application and build it into any type of conflict resolution into the application. Again, the big difference here is it's transactional based versus some of the log shipping. As we look at some of the enhancements in SQL Server 2008 for peer-to-peer replication, as we look at enabling additional nodes to a replication solution and then keep the replication process online. In previous releases of SQL Server, you basically had to take it offline to add new nodes. Also, SQL Server 2008 makes setup, monitoring, management pretty straightforward with the graphical topology viewer. Again, peer-to-peer replication could be used to provide local access to the whole orders database, and each site could be used as a failover if another site becomes unavailable. All right, well, let's take a look at a couple of questions as we take a look at our availability. So which statement does not apply to peer-to-peer replication? So here we're looking for what does not apply. What does not apply? I see some people hitting some of the things that we just talked about. So what does not apply? So again, some of the things that do not apply to peer-to-peer replication. So the topology viewer makes it managing and monitoring straightforward. Applications must be designed to connect to another node. Changes are allowed on any database, or the last one there, assist and backup and restore. So again, this is talking about peer-to-peer replication. We have a little bit over 50%. We're getting up there, 70 now. So the one that does not apply is number 4, or the green, assist and backup and restore. Remember, in SQL Server 2008, we have a new topology viewer that's going to help us as we look at managing and monitoring our peer-to-peer replication. As I mentioned, applications need to be designed to connect to another node. This is not like database mirroring where it's going to be automatic failover. It's not going to be like clustering where it's an automatic failover. Here we have to build into the application conflict resolution as well as the ability to connect to other nodes. And then obviously changes are allowed on the database. All right. So which statement regarding failover clustering is correct? So which statement is correct? Is this a new feature? I don't see anybody going for that one. Remember, I know that we've had this since 2000. Pretty sure we had it in 7 as well. So failover clustering's been around for a while, folks. Kind of mentioned again, failover clustering does have to have certified hardware. It has a shared disk array, special operating system. So it says does not require special hardware. Well, we know we need to have certified clustered hardware. But we're talking about protecting information, so we know that we're trying to prevent data loss. And there we have just almost 50%. Again, we do prevent data loss with failover clustering. That's what we're trying to do, high availability. And as I mentioned, you can geographically disperse. That was one of the bullet items there. But again, to kind of remind you of that conversation, geographically dispersed failover clusters does need to be on a certified Microsoft geographical dispersed cluster services configuration. And that's going to give you one or more storage arrays at each site. If that particular site, the server node, or the disk fails, then we're going to have that complete redundancy. So again, here we're preventing data loss. And taking a look at database smearing. So we're looking at, again, the negative here. So we did the negative, then positive, now we're doing the negative. Which statement regarding database smearing is not correct? And this one, to me, I'm going to say is we're going to say asynchronous, because to me, in synchronous, it's close to real time. So I kind of gave that one away, because to me, I think we need to put asynchronous in here if we're using database mirroring with asynchronous. Again, changes are automatically applied to the mirror. The client applications are automatically redirected to the mirror server. And with Enterprise Edition, we do extend some of the pages of data. So again, changes are not in real time. To me, that one could, it depends on how you set it up. Because if you go with synchronous, then it's really close to real time, because it's not going to go, I guess it depends on the latency of your link. So I guess it's one of those great computer answers that we all use. It depends. All right. Well, let's take a look at decreasing downtime. Fast database recovery. So those of you that have worked with bringing a system back up may have experienced this in SQL 2000. We introduced this in 2005 as well as 2008, called fast recovery, and that basically is changing the two-part cycle in restoring a particular database, where you restore the information and then you have the undo phase. So fast recovery makes the database available during the undo phase of the recovery process. So in SQL 2000, you had to wait for both processes to finish. You had the restoring process, and then you had an undo, transactional log, rollbacks, and such. So let's just take an example of a 16 gig file. So we have a 16 gig database, and in 2000, what we do is we're going to restore it, and 12 gigabytes of that information does not have to have anything applied to it. No undo process or anything. But guess what? We can't do anything to that entire database until the undo process for the 4 gig finishes. As we look at 2005 and 2008 supporting fast recovery, then that whole undo phase, if we go back to that same example with that 16 gig file, we have access to the 12 gig of the database, and that's immediate as it rolls into the undo phase of the recovery process. So again, you're not waiting for the two-part process to complete. And then, you know, that's what I would consider partial availability during the restore process. Then on top of that, as it is rolling through the undo phase, as those things are applied, then it as well becomes available during the process. So you don't even have to wait for the entire 4 gig to be the undo process. As it rolls things back, then you're going to get access as well. As we support fast recovery, what's that going to give us? Well, with SQL Server 2008, it's going to minimize the time to bring a database back up line. What does that mean? It means the users can get to the information sooner than if you had to wait for the entire recovery process to be completed before the users can actually connect to the system. I hope this is not your disaster recovery plan. Backup and restore. This is what I would consider a cold solution. We've talked about, to me, I look at clustering and I look at database mirroring as hot solutions. I look at some peer-to-peer replication and log shipping and things of that nature as warm solutions. This is what I would consider cold, because you're going to have a lot of your legwork to get the system up, and typically this is going to be we are down. But we do want to cover it because we want to make sure we protect information and talk a little bit about backup. So the backup media mirroring feature of SQL Server that we're introducing with 2008, performing a mirrored backup of a database to multiple backup devices. So that's going to increase the reliability of the backups in case of faulty media or a lost backup device. Now, typically what I do is I do backups to disk. I actually have extra disks in the system, and that's where I do my backups. And then those backups are then copied to tape. So it's kind of like my archive process. I typically don't back up the SQL Server directly to tape. I will back it up to a hard disk and then have that backed up at night from the backup software to copy my backup sets from the drive. Now, as we're looking at reducing the chance for failure, as we support the mirrored backups to both disk and tape, the device used must be similar to avoid the risk of a device mismatch error. All devices in a backup mirror set must be available during the backup process, but the database can be restored from any individual backup that is contained in the mirrored set. Another backup reliability is the generation of a checksum during backup operation, which is then used to verify a restored database. And then also, some changes in SQL Server 2008 that I look at great improvements. So one of the big ones is backup compression, which can reduce the volume of the backup sets close to 50%. The reduction in the volume can allow you to back up data more frequently, which was also going to help you with your restore times, typically reducing the restore times if you have more frequent backups. Now, backup compression can be set to on or off in a backup command, or you can use the sp_configure command to define the compression value on or off to be used by default when a backup is taken and you didn't specify that compression option. Also, one of the things that we talked about in the security session of our webcast series is that we now support, some of the encryption of the database. So, it's called transparent data encryption. And the actual demo that I did in that session was, I had enabled transparent data encryption for the entire database, and then I took a backup, and then I took the backup to another instance of SQL Server and tried to restore it. And because I was using transparent data encryption, I could not restore it on a different instance. So that's another great change, especially when we start talking about managing our backups and working with our backups. That's what I consider data at rest, which sometimes can be translated to data at risk. What is happening to the tapes and the information. I've seen where couriers have lost it, where you email, or I mean not email, but you overnight in a particular package to, an offsite location, and the tape gets lost. Where's your tape? So, in the past, depending on what you were doing with your backup routines, there was a chance somebody could go and restore that on another instance of SQL Server. So again, for more information on that, take a look at the security session that we did. I think that was part 7. If you want, you can email me and I'll get you the direct link. But that's transparent data encryption. As you look at some restore strategies with SQL Server 2008 Enterprise Edition, it does support online restore. It's going to enable you to access restored portions of the database. And again, even if the remainder of the database is not yet available, again, speeding recovery, reducing downtime, increasing availability. Additionally, you can use what's called a piecemeal restore strategy to restore a database in stages. For example, by restoring file groups that contain currently active data, bringing the database online before restoring file groups that contain older archived data. Capability makes it possible to reduce the amount of time mission-critical applications remain offline in a disaster recovery scenario. And then when you need to recover a database because of a small number of corrupt pages, in SQL Server 2008, we do support page-level restore operations. So you can identify the page ID of suspect pages in the database from a number of sources, including the suspect pages table in the MSDB, as well as the SQL Server error log, the DBCC check database. If you identify any pages that are potentially corrupt, you can restore them by specifying a page ID in a page clause restore statement. That ability to restore individual pages from a backup is going to help reduce the downtime caused by a database corruption. All right, so let's keep going. We've got a couple more review, and then I'm going to go in and I'm going to talk to you about a couple more topics before we close out today's session as we take a look at some other enhancements with SQL Server 2008. So again, which item is not a valid restore strategy? We've got online restore, quick restore, page level restore, piecemeal restore. And we got about 75% of the people coming in correctly with number 2, which is quick restore. The answer is quick restore. Online, page level, and piecemeal are optional restore strategies supported in SQL Server 2008. So which statement is not correct regarding our backup and restore? So again, which statement is not correct regarding backup and restore? So allowed mirrored backup of database to multiple backup devices. That's kind of what we were talking about. And then increases reliability backups in case of faulty media. All backup devices in a set must be available, and checksums are not available. We're going with a double negative here. Which statement is not correct regarding backup and restore? Making you think. This is like those certification test questions here. So the answer is, again, the double negative, got just about 50%. The answer is checksums are not available. That's true. Checksums are available. They're generated during backup and used to verify a restored database. So, again, which statement is not correct? Checksums are not available. Well, checksums are available. As I mentioned at the beginning also, when we're talking about backup, the backup now supports mirrored backups. We can go to multiple backup devices, so that one is correct. We also are going to reduce the reliability of backups in case of faulty media because of mirrored backup of databases to multiple backup devices. And then, as we mentioned, all backup devices in a set must be available. So, again, checksums are not available. Double negative here. Great Microsoft certification test there. All right, so do one more, and then we'll go in and do some demos. I see a couple of you just jumping all over this one. Awesome. Which statement regarding fast database recovery is correct? So increased time necessary to bring a database online. Well, that would kind of be opposite of what we're talking about today, wouldn't it? Makes the database available during the undo phase, works only for crash recovery, no availability during restore operations. Got about 70% of you coming in right on target here with number 2 or the blue one. Again, the answer is it makes the database available during the undo phase. Fast recovery makes the database available during the undo phase of the recovery process with partial available during the restore operation. All right, let's get in and do a couple more things in some of the demos. So I got a couple things I want to show you. Again, around availability. So we're going to introduce another concept around what's called snapshot isolation. And with snapshot isolation, we're looking at turning the dial from a pessimistic locking scenario to an optimistic locking scenario. Now, I will warn you that if you do move into snapshot isolation, you want to make sure that you have the appropriately sized temporary DB, so your temp DB, because that's what it's going to use to write the information in as we go through snapshot isolation. So as we look at snapshot isolation, it's going to be used to present a transactionally consistent view of the database without the wholesale locking typical of a serialized isolation level, or what I consider pessimistic isolation. Now, an example might be a suite of financial reports where the numbers on the last report must tally with those on the very first. As we look at the reports, you look at, how do you implement the reports against the read-only replica of the system? What if things changed? How do you get the updates? You want to make sure you don't disrupt, your production activity. What about doing the reports overnight, shutting down the online application? So as we look at making some changes to go, towards a optimistic, we can, look at having an isolation application mode to actually, simultaneously support both scenarios. So I have a little application here that we're going to use, and we're basically going to simulate 2 concurrent users in the database and examine the impact on each other, because that's what we're looking at as we look at, pessimistic versus optimistic locking, is that, the users are affecting each other. So again, if your users aren't waiting, and again, you can use the SQL profiler to see, what's happening with your locks, stay in pessimistic. But if you want to look at, turning the dial, you can invoke what's called snapshot isolation, and then it's going to use the temp DB. So we're going to see that the lock footprint has completely changed, even though we have what's considered a serialized view of the database. So let me go ahead and connect in here. So I'm going to connect left, and I'm going to connect right. And we're going to start with read committed here. And I'll go ahead and click my begin button. And then we'll do a refresh. And we've got some numbers. And we're just going to work with these row data values and make some changes to see what's happening. So that way we can take a look at update blocks and see what happens with some conflict. So I'm just basically going to come in here, and I'm going to change this to 1. And as I change that to 1, notice that we've gone to pending. I have not committed, so I'm pending. As I go over here, I'm going to refresh. Again, I'm in read uncommitted here. Actually, I want to change this to read committed. Let me go ahead and change. I'll roll back here and go to read committed. So we can see we refreshed here, but let me see what I'm going to do over here. So change this to 1. We're going to go out and update. So let's keep going and actually see what we can get to happen here. So I'm going to roll back and roll back. And again, we're going to refresh. And let's actually change this to our transactional isolation level. Come on, I want transactional base. For my snapshot, and we'll say begin. And we're going to change this to transactional base for our snapshot. And begin, and we'll refresh. And let's see what happens when I go and make some changes here. So again, I have pending. As I come over here, refresh, notice I don't have the update. But I want to make some changes. And again, you're going to say, hey, timeout's expired because I have the locking in place here where what's happening is it knows that in the temp DB, things have changed. So it's saying that the timeout, we're having an issue. Again, seeing some of that serialized view of the database. Now, with snapshot isolation level, it's not going to allow multiple edits of the same data because it does follow the same locking semantics of our other isolation levels. Let's say I committed over here and then refresh. Got this thing changing up here for me. Let me commit. We can see we have it at 2. Let's see if we can get it to refresh over here. You can see that it's still reading from the temp DB. Let me roll back out and roll back out. Let's take a look at read uncommitted. See if we can get it to start here. We can see we have the uncommitted here. We have the 2. Let me change this to a 3. Again, it's pending. And if I go over here and try and change it, let's say to 4. Again, we're seeing the locking and what's actually happening against us. So you can see that as somebody's working, even though they haven't committed, then we're going to have issues with getting access to the data. So let's roll back out. And let's take a look at, see if we can get some snapshot isolation data conflicts. So again, I'm going to go to snapshot here and refresh. Snapshot here and refresh. So we're back in sync with the 2. And if we look at snapshot isolation transactions, again, they don't start until we touch the data. If we issue to begin transaction, then we're going to get some update changes. Now this non-blocking behavior is what's called snapshot isolation. So let's go ahead and try and make a change here. So I'm going to hit 3. And we'll hit the refresh. So as I refreshed it, now it's seeing that I've made changes, that I'm at the 3. Let's go ahead and hit the right. And again, when we edit the row down in the right condition, our pending update is going to be blocked and will time out because of what's happening over here. So now I'm going to go and I'm going to commit as I go to commit. Then when I refresh, I see the changes to the 3. If I come over here and refresh, I'm going to get the commit changed on me from read uncommitted to from snapshot. See if we can get it to come up with a 3 here. It's not happy. So let me go back. You can get to refresh and get to 3 here. There. So I had to roll back my previous change of trying to make it 4. So here I have, again, back to my 3. So we can see that it has updated. So as you can tell from this demo, transactional rollbacks can be an expensive operation. Log data might need to be rewound to undo the rest of the changes as we look at managing these conflicts. So this is a primary reason to ensure that applications make wise decisions about the transaction isolation strategy they use. If we have update conflicts as we work with snapshot isolation, if we have long-running update transactions, we might have risk to actually roll those back. So here I just kind of tried to show you some of the pains of dealing with some of the locking capabilities and what happens to users as we have the different locking mechanisms in place. Now, as we look at implementing snapshot isolation, what you actually do is you start to move the information from the locking mechanism into the temp DB. And there's actually 2 levels that you can run into the temp DB using the snapshot isolation. And that is basically what I would consider a read-only view where, as things are being updated or changed, it reads into the temp DB, and you have basically what's considered a static view of the information. Then you can turn the dial up a little bit more and actually have it where you get the changes in the temp DB live as it's being updated. So it does add a little overhead. But again, are you having users wait? Are you having different information or errors, locking like we just saw, trying to demonstrate some of the pains of the locking mechanism in place. So another one that I kind of want to touch on, pretty straightforward, has to do with database snapshots. And with database snapshots, again, they're unrelated to snapshot backup, snapshot isolation of transactions, or snapshot replication. We love the word snapshot on the SQL side. Database snapshot is that read-only static view of a database. It's basically the source of the database. Now, multiple snapshots can exist on a source database. They always reside on the same server instance as the database. Each database snapshot is transactionally consistent with the source database as of the moment of the snapshot's creation. Now, snapshot does persist until it is explicitly dropped by the database owner. So what can we use snapshots for? We're going to use that for reporting purposes. In the event of a user error on a source database, maybe you're going to revert the source database to the state it was in when the database snapshot was created. Data loss can be confined to the updates to the database since the snapshot creation. So I just wanted to show you a quick command here in my SQL script. As you can see, I don't have any database snapshots. So we're just going to say use the test database, create a database. We're basically going to turn on for our snapshot, and then we're going to give it the file name. So I'm just going to click in here and execute. And we'll do a refresh, and we should see the database snapshot. So now I can actually go in, and I could actually use the information. Let's just kind of look at, see if we can go find that out there. So I'm just going to go into my computer. That was in program files. And that's on Microsoft SQL. Open that up a little bit here. SQL Server. And then MS SQL.1. And data. And I'm going to look at the test DB. Now look at that size. Let's just go and take a look at it. As we look at the properties, so you can see there that even though it says it's 2.18 meg, the actual size is 384. So it's using the NTFS parse file system. It actually will allocate the size that it needs, but it's not a direct copy of everything that's on the database. It's not, when we think of taking a database snapshot, it's not what I would consider a full-out picture of the database. When do things get written? Things are going to get written to this file as changes happen in the system. So it's allocated a space, but the only thing that's there right now is basically all pointers because nothing's been changed in the system. So let's go ahead and open up another file here. And we're going to say we just want to delete product ID 40. Had it highlighted, so it's deleted it. So let's just go ahead and do another query to see if 40 was deleted. And we see we got 10, 20, 30, 40 is gone, 50. Let's see what happened over here. Look at there. It jumped up in space. Because now 40 was changed. We deleted it from the system. So 40 is no longer in the main database. What do we have in the main database? Well, we have 10, 20, 30, and 50. Okay. 40 is now, because it was changed or deleted, we actually deleted it, the original value for 40 is now living in the snapshot. Where's 10, 20, 30, and 50? Well, they're just pointers back. There's pointers here pointing back to what's actually in the database. This is going to save hard drive space, and it also adds the, what I would consider, the logistics of how we're storing the database snapshots. Don't think of it as, I have a 4 gig database. I took a snapshot at 8 a.m. It took up 4 gigs of space. Why is this important? Well, it's important to know how to manage it because it's not just a direct picture. It's going to be pulling some information from the live database, which could affect performance if we're running reports against the snapshot. Also, if we were to have a catastrophic failure, some of the information might not be there. It might be there, it might not be there. It depends on what's changed. So you start to look at what's in the system. a foundation level of how things run is critical when we start looking at our database snapshots. So again, as we saw here, we deleted the 40, and when we did that, we're jumping up on space here. All right, so I'm going to switch virtual machines, so I need to go back just a moment, and then I'm going to shut down one of my virtual machines and bring up one of my other virtual machines. And we're going to go into that one in just a moment, and we're going to take a look at another side discussion. We talked about availability. This is one of the performance changes to SQL Server 2008 that I think kind of plays into our discussion today as we look at, from a performance perspective. Because if we have a particular process or something that's running on the system, it could be causing users to wait. We're talking about availability. And so let me kind of show you what we're going to talk about right now for the last couple minutes as we wrap up today's webcast. And that has to do with one of the new features called Resource Governor. So here I have Resource Governor. And this is one of the demos that I've been showing at the launch events. So I brought up one of my launch VPCs. We have a resource pool here. And here's the created by default system resource pool. And then I went and I created my own that's called low importance. So I created my own pool, very straightforward. As we go into the resource governor, we just right click. And we can call it new resource pool. So maybe we'll call this one DBA. And let's say minimum is 50, maximum 75, 50, go 75, let's click OK. So now you can see I have BVA. So underneath that I have my workload group, and let's bring up the one that I've already created. It's called low importance, and you actually see the internal and the default. We're going to work with those in just a moment. And then low importance. So the maximum CPU here is 10, and then the maximum memory is 10. So let's see how this can affect our performance and help us to make sure that we have the proper resources to make sure that we have our availability. So here I have my performance monitor running. We can see that I'm going after my CPU usage on my SQL Server. It's my SQL resource pool. And the two pools I'm working with are default and low importance. So I have a couple of VBS scripts. They're actually the same script. I'm just going to bring it up. The difference is this one's called low importance application. So that forces it into the low importance pool. So notice again, low importance is pink, and then yellow is our default. So first, to show you the dynamic nature of our resource governor, I'm going to start the low importance application because it's not a hard limit. So as you can see clearly, I jumped way up here above 10%. I told it only 10% CPU and 10% memory. We're looking at CPU, but it's only going to govern if there's other workloads. So let's launch that other workload. And again, it's going to be dynamic. So we're going to see an inverse relationship. So as I start mission critical, notice mission critical is going to peak up. And as we have a peak on mission critical, notice that's where I'm going to see that 10% drop here. Now notice in this delta right here, my mission critical app didn't need a lot of resources. So it was dynamically allocated back to the low importance. And you can see this trend building across. So it's only when a particular workload is going against something that you've decided to govern that you start to see that relationship. So, and again, that is the resource governor. which I think does play into our discussion today around availability. So just a couple demos that I wanted to put together to show just some of the new things that we have as we look at availability. So as we wrap up today's session, we're looking at, implementing increased availability to take advantage of different features such as our database mirroring. We can configure database mirroring to apply changes of the mirror in real time or near real time. Again, synchronous versus asynchronous. We're going to allow you to specify the level of protection and the performance overhead on the system. As we look at implementing always-on technology, then we have the ability to increase protection against system and hardware errors, reduce the number of recovery times. So we kind of give you some of the different strategies that we went through today's session with some log shipping, with peer-to-peer replication, what I consider warm capabilities. We do have backup and restore, what I consider cold. And ultimately, we're trying to decrease downtime. One of the ways we can do that is with fast database recovery. Again, with Enterprise Edition, we can have fast recovery during both crash recovery and database mirroring failover. And then to show you a couple of new things, some of the things that we talked about, again, tying into availability with snapshot isolation, the ability to, try and open up some of the locking. We saw some of the frustrations that an end user might have trying to get to the information in the locks, where we can actually change the locking and move it to the temp DB area and actually have them read information from the temp DB. And again, two modes of the snapshot isolation: the ability to work, from a read view and then a transactional based view as things are being changed. And then we also took a look at database snapshots, and I tried to show you some of the technology behind it so that you know how database snapshots. It's not just a copy of the database. So we took a look at what we can do on that. So coming up next, this is on Wednesday, and I believe this will be Chris Avis. I'll be in Charlotte, North Carolina, delivering the launch event, and I'm doing a licensing boot camp at the Microsoft office on Wednesday. So I believe Chris Avis will be delivering our next session as we take a look at replicating data with some of the replication services. So, got a couple questions as we get ready to finish up. It says, let's see, we do not need a license for the mirror server for only 30 days. I mean, when it's failed over to the mirrored server. So, to set up mirroring, you do not need a SQL Server license as far as setting up the system. When you do that, you only have one instance of SQL Server that people are interacting with. In this, situation where the mirrored server has gone over, well, it depends. The mirror can take the role of the primary. Typically, you are going to run it back, so that once you get the primary back up and running. I'm not aware of the 30 days, but, if you, look at if the server was completely down, then you can look at, what can you do to transfer the license from the other box to this box. The idea is that mirroring is included with the purchase of the system. The mirror can take on the primary role if the primary goes down. Typically, once the primary comes back up, you do a synchronization and you make it the primary again. What is your recommendation for the number of active online transactional processes, databases to mirror? Again, that's going to depend on, your workloads and the instances of SQL Server. Add on some of the SQL performance sites. You got obviously some sizing stuff from Microsoft, but there's a couple other, LLTP data sites that show what they would consider workloads, because that's going to depend on how many instances and what's your existing hardware. Similar question, how many databases can be put on a 2008 database mirroring solution? I'm looking for a max here. Again, the max is going to be dependent upon your hardware and your connectivity. Obviously, you're not, going to have what I would consider, a WAN link that's going to have 10 databases being mirrored across the WAN, because the link's probably not going to be able to handle that. There are significant changes as we go to release SQL Server 2008. We'll probably get some more specs on what I would consider the recommendations, because there is what I consider a drastic change in the log compression utility used to keep the SQL servers in sync. So with that, I got just a couple others in there that I will do offline. As I mentioned, we were trying to go hour and 15, so we'll give you close to 15 minutes back as we wrap up today's webcast. So Phil, if you can tell them how to fill out the survey, we'll get that taken care of and wrap up today's webcast.
All right. Thank you a lot, Brian. Ladies and gentlemen, as Brian just mentioned, there is a survey that should be appearing on your screen shortly. If you would not mind taking a moment to fill this out prior to exiting the room. And I'd like to also remind you that the slides are available to print directly to PDF from this console, and you may do so by hitting Control-P on your keyboard, or you can go ahead and click on the printer icon in your lower right portion of your console. And with that, that does conclude today's presentation. I'd like to give a special thanks to Bryan von Axelson, and thank you all for taking the time for today's presentation.